this is another example of finding the domain of a composite function. In this case, we're dealing with rational functions, which, I don't know, I prefer these over square roots, but we'll see what you think. The first part of this question, before we get into the details, the first part of this question is just saying, find the composite function. Okay, so I want the composition of these guys. There's nothing about domain there. Then the next three parts of this question are really domain questions. And I can answer these two, anyway, very quickly. We've done this stuff before. What's the domain of m of x? Okay, well, write m. Hold on. I know x minus 5 is not allowed to be 0, right? You cannot divide by 0. So that means x cannot be 5. Easy. So we just say all the numbers except 5. Negative infinity to 5, union 5 to infinity. Okay, no problem there. Next one says what? Let's see. Let's change colors so I don't get too crowded here. This guy says x plus 1 cannot be 0. So that means x cannot be negative 1. So we just use all the numbers except negative 1. Negative infinity to negative 1, union negative 1 through infinity. Now, we have to deal with the composition part of this problem, which is m of h. That's what we're doing now. So I'm going to do this part below, and then we'll talk about finding the domain of that thing. So m of h, what that means is, well, the way I always think about these, if I'm looking at that, m compose h, I rewrite this. Right? I literally write it over again as m of h of x, like that. And that reminds me what the order is that I should do these things. I take the m equation first. Okay, write down the m equation. That's going to be something plus 1 divided by something minus 5. That's m. Now into that, you put h. So here goes h right here. X over x plus 1 and x over x plus 1. Oh, it's terrible. It's a compound fraction. You guys remember how to deal with these? We just multiply by a crazy 1, which will get rid of those denominators. Okay. Hopefully you've done this a few times before. So multiply this guy through top and bottom. So in detail, what I'm going to be doing is taking this particular variable, multiplying it by the top of the numerator, and I'm taking this one and multiplying it by the top of each of these denominators. All right? Getting a little crowded though, so let's wipe that away and just go ahead and see what we get. On the top left of this fraction, the x plus 1's cancel out. I just have x plus 1 times x plus 1. On the bottom left of the fraction, the x plus 1's cancel out. I just have x minus 5 times x plus 1 on the bottom right. Okay, so what do we get from that? That is going to be x plus 1 over x minus 5x minus 5. Watch that minus sign. And that simplifies down to x 2x plus 1 over, what do we have here? Negative 4x minus 5. Okay, that is the composite function. What was this thing? M of h of x. Okay, so that's the first part of your problem, when you had to find the simplified form of m of h. I can't simplify it anymore because there's no GCFs that are going to cancel out. So now let's find the domain of this thing. Okay, the domain of a composite function comes from two places. Well, I mean, it comes from domain restrictions, and those domain restrictions come from two places. You have the domain restrictions of your inputs, which in this case is h of x. You also have the domain restrictions of your outputs, which is m composed h. I keep wanting to write f. M composed h. All right, so h of x itself was, where's my h of x? X over x plus 1. Nice and easy. Okay, h equals x over x plus 1. Well, there's no square roots to worry about, so the only thing I have to watch out for is dividing by 0. That means x cannot be negative 1. And then if I look at the output, that one's more complicated. If I look at the output, here, let me switch colors for a moment. This guy, that tells me that negative 4x minus 5 cannot be 0. Okay, so that's negative 4x cannot be 5, which is x cannot be negative 5/4. So here are my two domain restrictions. Whoops, not that one. Go away. This one and this one. So when you write your domain, you write it this way. You say all the numbers in the universe except those two. Negative 5/4. And then from negative 5/4 to negative 1, make sure you know which one of those is bigger or smaller. That affects how you write this thing. And then from negative 1 to infinity. Okay? Kind of funny, if you were to look at the original problem, which is m of h, you would not see this guy, negative 5/4, anywhere in it. You have to do the composition before you can be sure what the domain restrictions of the composition are. Those come from the input function and the simplified output function.